What's happening now is we're moving away from linear equations. We're going to deal with quadratics and higher order cubics, polynomials, 4th, 5th, 6th degrees. But this one, we're talking about complex numbers. Instead of writing the word complex numbers, I'm going to use CNs from now on. But before we define complex numbers, let's review radicals. Square root of 4 equals what? 2. Square root of 36 equals 6. Square root of 8 . So here the question is now we can solve this one. How do we get 2 for square root of 4? What is 4 made up of? 2 and 2. Once we have a pair of numbers, that number goes outside the radical. There's nothing left. Same thing here. 36 is made up of 6 times 6. There's a pair of the numbers, the same ones. They're coming out. But how about square root of 8? What is 8 made up of? 4 times 2. 4 is 2 times 2. So 8 is 2 times 2 times 2. It's a square root. There's an invisible 2 right here. There's an invisible 2. This is called the root. It tells us how many of the same number do we need to take it out of the radical. We need, in this case, 2. We need 2 of a kind, 2 of a kind. So here we have 2 of a kind. So they come out as a 2. Whatever's left stays inside the radical. Likewise, 37. Not 37, 27. Let's do 27. 27 is made up of what? 9 times 3. 3 times 3. So 27 is 3 times 3 times 3. There's 2 of a kind. So it comes out in front. Whatever's left stays inside. So that's how we simplify radicals. How about if we had cube root of 8? What would that equal? Again, break down 8 to its smallest numbers. 8 is 2 times 2 times 2. That number tells us we need 3 of a kind to take it out. Of the radical. We have 3 of a kind. So the answer is 2. So far, so good. So with this process here, these little trees that I'm doing is called prime factorization. I break it down to its prime numbers. What are prime numbers? Very good. Numbers that are only divisible by 1 and itself. So this is what we need to know first, because complex numbers builds off of this stuff. There's also a property of radicals that we need to know. If I have a product of two numbers inside a radical, I can take that and split them up. Actually, this is a good way of proving this. What is 8 made up of? 4 times 2. According to this property, I can take both of these numbers, put them under their own radicals. Square root of 4 is 2. Radical 2. So that's a perfect example of how we can do it and why we can do it. Now, we haven't gotten any closer to defining complex numbers. For another number system to exist, there has to be a reason for it. And here's the reason. Solve that. Remember, whatever multiplies in that has to be exactly the same number. 2 times 2 is 4, but not negative 4. Negative 2 times, so 2 times 2 is positive 4. Negative 2 times negative 2 is positive 4. The problem comes whenever we have square roots with negatives inside there. The shortcut method is this. If you have a negative inside there, just put an I out in front. So this I means that there used to be a negative inside there. Square root of 4 is 2, so 2i. Pretty simple. This I represents imaginary numbers. I is an imaginary number. It's got a value. We can't touch it. The value of I is the square root of negative 1. You can't graph it. It's imaginary. So now, with this concept, and what we just talked about a second ago, we can now have a better understanding of how to solve this. Negative 4 is actually negative 1 times 4. Oop, not this. Because they're a product, I can split them up. Square root of negative 1 times the square root of 4. Square root of -1 is I. Square root of 4 is 2. So the answer is 2I. That's how we're going to be using to solve imaginary negative radical terms. So far, so good? So let's define a complex number. Complex number looks like this. A plus BI. The reason they call it complex because it's made up of two different types of numbers. It's made up of a real number, A, and it's made up of an imaginary number, B, I. That's the reason it's called complex. So, is 2 a complex number? Okay. Can you write 2 in this format? 2, is there an I term? So 2 is a complex number. It's just that B value is 0. 4I is 0 plus 4I. The A term is 0. Or we can have anything else where A and B are integers. Integers are anything from negative to positive infinity. So far, so good? So that's what complex numbers are. Whenever you hear the word complex numbers, it's practically everything under the sun. All right. Let's talk about the algebra of complex numbers. This is going to take us the longest part. When we talk about the algebra of anything, all we talk about is addition, subtraction, multiplication, and division. That's what we talk about. So in other words, the algebra of complex numbers is adding, subtracting, multiplying, and dividing complex numbers. Let's look at addition, subtraction first. There's basically one rule. Combine like terms. So we have, let's say, 2 plus 5i plus -6 plus 2i. The order of operations always exists, always has to be followed. According to the order of operations, the first thing we're supposed to do is, can we do anything inside the parentheses? No. This is an I, this one doesn't have an I, so we cannot combine them. So if we can't do inside the parentheses, we have to get rid of the parentheses. What number is in front of the parenthesis here? A 1. I used to say if there's nothing there, just drop the parentheses. But that gets dangerous when we talk about subtraction also. You can't just drop parentheses around subtraction. So let's just distribute. 1 times 2 is 2. 1 times 5 is 5i. Same thing here. Positive times negative is negative. 1 times 6 is 6. Positive times positive is positive. 1 times 2i is 2i. Whenever you get rid of parentheses, you always have to combine like terms. Positive 2 minus 6. The 6 is bigger, so the answer is negative. 6 minus 2 is 4. Then the imaginary numbers. 5i plus 2i. They're both positive, so it's 7i. There's your answer. So it's pretty straightforward. Let's try a minus a subtraction one. Three minus 4i minus 5 plus 6i. So since we can't do anything inside the parentheses, let's get rid of the parentheses. 1 times 3 is 3. Positive times negative is negative. 1 times 4 is 4i. Now, this is where it's a problem. If we just drop the parentheses here, what would happen? It would be negative 5 plus 6i. But if we distribute, negative times positive is negative. 1 times 5 is 5. Negative times positive is negative. 1 times 6 is 6i. So the negative in front changes the sign of everybody inside the parentheses. We get rid of parentheses, combine like terms. 3 minus 5. 5 is bigger than 3. Answer is negative. 5 minus 3 is 2. The imaginary parts, they're both negatives. The answer is negative. Add the numbers. 6 plus 4 is 10. And there's your answer. It didn't say it was hard. Let's expand this one. 2 negative 3 plus 2i plus 3 2 plus 5i minus 5 2 minus 3i. You don't have to stay with only two numbers. You could expand it as many terms as you want to. So what do I do first? Distribute, yes. Negative times negative is positive. 2 times 3 is 6. Negative times positive is negative. 2 times 2 is 4i. Positive times positive is positive. 3 times 2 is 6. Positive times positive is positive. 3 times 5 is 15i. Negative times positive is negative. 5 times 2 is 10. Negative and negative is a positive. 5 times 3 is 15i. Try to get used to get in the habit of doing the signs and the numbers separately. It will limit the amount of mistakes you'll make. Combine like terms. We have 6 plus 6 minus 10. 6 plus 6 is 12. Minus 10 is 2. Negative 4i, 15i, 15i. Because there are 3 terms, I can use associativity property. I want to add 15i plus 15i. What's 15 plus 15? 30i minus 4 is positive 26i. If you have a series of numbers, you can pick which ones you would put together first. It makes life much easier for you. So that's addition and subtraction. Any questions? Let's do multiplication. Multiplication of complex numbers. Two times 3 plus 5i. All this one is distributivity. Positive times positive is positive. 2 times 3 is 6. Positive times positive is positive. 2 times 5 is 10i. Instead of a 2, let's make it a 2i in front as a coefficient. So positive times positive is positive. 2 times 3 is 6i. Positive times positive is positive. 2 times 5 is 10. What is I times I? I squared. Very good. Basically, all this exponent tells us is how many i's do we multiply together? Only 2 of them, so it's a 2 up there. Yeah, we have a problem here. Houston, we have a problem. In complex numbers, you can never have an exponent on the I. So we know that I is equal to the square root of -1. What would happen if we squared both sides? Now, I squared, those cancel, equals -1. So anywhere you see an I squared, replace it with a -1. Actually, it means something else even easier in a minute. So here we have 6i plus 10 times -1. Positive times negative is a negative. 10 times 1 is 10. So here's the true function of an I squared. If you have an I squared, just eliminate it and change the sign of its coefficient. That's all it's doing. We got rid of the I squared and change the sign from +10 to -10. That's all it does, is change the sign in front of it. But we cannot leave our answer in this form. Why not? What's the complex number form? A plus bi. The real number has to go first. So our answer would be -10 plus 6i. That's the answer. Okay, with that, let's go and expand our numbers. 2 plus 3i, 5 plus 2i. So what method are we going to use to multiply these two together? Anybody remember those 4 letters? We're going to use the FOIL method. First, outer, inner, last. Basically, okay, FOIL method only works if you have binomials. In other words, each one of your parentheses only has 2 terms in it. No more, no less. So basically, what this method really tells us to do is distribute. Everything in this first parenthesis multiplies to everything in the second parenthesis. So let's look at the first one. Positive times positive is positive. 2 times 5 is 10. Then the next one, because this first one has to multiply both of those. Positive times positive is positive. 2 times 2 is 4i. That does it for that one, because it's finished in both of those. Now the next one. Positive times positive is a positive. 3 times 5 is 15. I. Positive times positive is positive. 3 times 2 is 6. I times I is I squared. Combine like terms. Right now, those are our like terms. Positive 4 plus positive 15, they're both positive. 15 plus 4 is 19. Plus 6i squared. Remember, whenever you have an I squared, what does that do? It changes the sign of the number in front of it. So from positive, it changes to -6. So we have 10 minus 6 is 4 plus 19i. Five minus 3i, -2 minus 4i. How do I know I'm multiplying these two together? What tells me I'm multiplying? Right. Yeah, basically, there's nothing between the two parentheses. Multiplication is the only operation that doesn't need to have anything there. If there's addition, there has to be a plus sign. If there's subtraction, it has to be a minus. If it's division, it has to have some division symbol. So if there's nothing there, it's automatically multiplication. So positive times negative is negative. 5 times 2 is 10. Positive times negative is negative. 5 times 4 is 20. Negative times negative is positive. 3 times 2 is 6. Negative and negative is a positive. 3 times 4 is 12. I times I is I squared. Combine like terms, negative 20 plus 6, they're different signs. So take the sign of the larger, which is minus, and subtract them. 20 minus 6 is 14. This I squared changes that to a minus, so it's a minus 12. Negative 10, negative 12, they're both negative. 10 plus 12 is 22, minus 14i. Is everybody okay with multiplication so far? Good, because now we're going to show you some special functions. All right, the first one, 3 plus 4i, 3 minus 4i. Multiply those two together. So 3 times 3 is 9. Positive times negative is negative. 3 times 4 is 12i. Positive times positive is positive. 4 times 3 is 12i. Positive times negative is negative. 4 times 4 is 16i squared. Combine like terms. This I squared changes the sign from negative to a positive. 9 plus 16 is 25. Let's practice some more. Negative 1 plus 5i, negative 1 minus 5i. Negative times negative is positive. 1 times 1 is 1. Negative times negative is positive. 1 times 5 is 5i. Positive times negative is negative. 5 times 1 is 5i. Positive times negative is negative. 5 times 5 is 25. I times I is I squared. Plus 5 minus 5, cancel. This I squared changes that sign from a negative to a positive. So we have 1 plus 25 equals 26. Again, it doesn't matter how small or how large the numbers are. It's the same process. 5 minus 6i, 5 plus 6i. Positive times positive, 5 times 5 is 25. Positive times positive, positive, 5 times 6 is 30. I. Negative times positive is negative. 6 times 5 is 30. I. Negative times positive is negative. 6 times 6 is 36. I squared. The 30s cancel since they're opposite signs. I squared changes that to a plus. 25 plus 36, 61. Now, let's do those without writing anything else down. Yeah, so 7 plus 2i, 7 minus 2i, the answer is going to be 53. Give me any two numbers. Four plus 8i, 4 minus 8i, 16 plus 64 is 80. These numbers, if you notice, these numbers each have only one thing different. What are they? Yeah, the sign in front of the I term is different. That's the only thing different. We call these guys complex conjugates. It's when you change the sign in front of the imaginary term. The signs have to be different. The numbers are the same, signs are different. This is what you have. A plus BI times A minus BI. The shortcut is simply that. Don't worry about the negative or positive because when you square it, it becomes positive anyway. So we just look at the numbers. So if you have the same numbers, only thing different is the sign in front of the imaginary term is different. Let's look at these. 3 squared is 9. 4 squared is 9 plus 16 is 25. 1 squared is 5 squared is 25 plus 1 is 26. 5 squared, 25. 6 squared, 25 plus 36. So that's a shortcut. You don't have to do all that foiling stuff now. Only on these type of equations. Now, why did we learn this? What's the only algebra part we haven't talked about yet? Division. We've talked about add, subtract, multiply. We haven't talked about division yet. Division of complex numbers. It only has one rule. You cannot have an imaginary number on the bottom. That's the only rule. If there is an imaginary number on the bottom, we have to get rid of it. We have two types. Remember, a fraction, numerator is on top, denominator is on the bottom on every fraction. That's what they're called. So the first type, monomial denominator. The first type deals with a monomial denominator that's imaginary. Monomial means one term. For example, 2 divided by 3i. We can't have an I on the bottom, so how do we get rid of it? Multiply both top and bottom by I. What is I divided by I? Any number divided by itself is what? 1. So all I'm doing is multiplying by 1. I'm not changing the number. I'm just changing the way it looks. So 2 times I. 3i times I is 3i squared. What does I squared do? It changes the sign of its coefficient. Typically, common convention of mathematics says that we don't want a negative on the bottom. So if you have a negative on the bottom, just bring it up on top. And there's your answer. It's not wrong. It just looks weird if you have negative on the bottom. Just bring it up on top. Okay, do that one. So what do we multiply by? I over I. Negative 4i. 5i squared. This I squared just changes the sign of that, so it becomes -5. Negatives cancel. We're left with 4i over 5, and there's our answer. The numerator could be a complex number. Okay, we only look at the bottom. The bottom has an I in it. So how do we get rid of the I on the bottom? Multiply I over I. So we multiply the I to the top. So it's 2 times I is 2I plus 3i times I is 3i squared. I times I is 3i squared. Can you cancel the 3i squares? No. Because the top number is a number as a whole. It belongs one group together. But here's the reason why. If we had 3 over 5 plus 1 over 5, that equals what? 3 plus 1 over 5 makes it 4 over 5, right? Look at this. Since there's a plus sign, what if we had 3 plus 5 over 5? And we canceled one of these 5s. What do we end up with? I know everybody says 3. When you cancel 5, you get a 1. 3 plus 1. But if you went the other direction, 3 plus 5 is 8. Are they the same thing? No. 8 over 5 is not the same thing as 4. 4 is wrong. It's got to be 8 over 5. So whenever you have a plus or minus on top and bottom, it's one number. They have to stay together. So this I squared changes that coefficient. The I squared changes that coefficient. So it's minus 3, minus 3. This negative sign goes up on top. 2i minus 3. So it changes negative 2i to plus 3. Are we done? Why not? Right, we have to put it in the standard form. So it's 3 minus 2i over 3. There's your final answer. Yeah, so we're reviewing a lot of math there. That negative sign goes from the bottom to the top, so it changes all the signs of the numerator. And I put it back in normal order, complex number order. We'll call that the standard form. All right, let me give you one more of these before we go to bigger ones. Simplify that one. You should be finished by now. Can't go any further. You're done. There's no I on the bottom. Trick question. Remember, only if an I is on the bottom do you have to, what that's called is rationalize the denominator. Getting rid of the imaginary numbers. All right, the second type, if we have binomial denominators, what that means is on the bottom of our equation, of our fraction, we have a plus bi. Four, 3 over 4 plus 5i. So since there's an I on the bottom, what do we multiply by? We multiply the top and bottom by the conjugate. So you multiply the top and bottom by the conjugate. So 3 times 4 is 12. Positive times negative is negative. 3 times 5 is 15. I. On the bottom, we know the shortcut. Just take the two numbers, square them, and add them together. 12 minus 15i. 16 plus 25 is 41. There's your answer. Let's do negative 2i over 3 minus 2i. multiply by the conjugate, top and bottom. Negative times positive is negative. 3 times 2 is 6i. Negative times positive is negative. 2 times 2 is 4i squared. And the bottom 3 squared plus 2 squared. On the top, that I squared changes the sign of its coefficient. So we have negative 6i plus 4. 9 plus 4 is 13. Fix the top. So it's 4 minus 6i over 13. Let's do a couple more. Five minus 2i over 3 plus 4i. These are equations. First step is multiply by the conjugate. The conjugate is always the bottom of the bottom number. Changes sign in front of the I. Five times 3 is 15. Positive times negative is negative. 5 times 4 is 20i. Negative times positive is negative. 2 times 3 is 6i. Negative and a negative is a positive. 2 times 4 is 8i squared. Combine like terms. So negative 20 minus 6 is negative 26i. The I squared changes that plus to a minus 8. N 3 squared is 9, 4 squared is 16. 15 minus 8 is 7. Minus 26i over 25. Everybody okay with this process? Okay. You want to do another one? You're going to move on. Who wants to do another one? Raise your hand. Throw me $1. No, just kidding. Want to do another one? Yes or no? Okay, let's do one more, and then we'll finish up the section. -3 plus 5i, -2 minus 7i. I always put parentheses around the numerator and denominator because I know those are individual numbers. The conjugate is what? -2 plus 7i. Because the only thing you do is change the sign in front of the I on the bottom. That's your conjugate. So negative times negative is a positive. 2 times 3 is 6. Negative times positive is negative. 7 times 3 is 21i. Positive times negative is negative. 5 times 2 is 10i. Positive times positive is positive. 5 times 7 is 35i squared. And since it's conjugates on the bottom, just take the first and second number and square them and add them. 2 squared plus 7 squared. Combine like terms. -21 minus 10, they're both negative, so it's 21 plus 10 is negative 31i. The I squared changes the sign of the 35, so it's minus 35. 4 plus 49 on the bottom. 6 minus 35. 35 is bigger, so it's negative. 35 minus 6 is 29. 49 plus 4 is 53. Everybody okay? Last topic. Here's a rule. I cannot have an exponent. If it does, we have to fix it. For example, I to the power 35. You cannot have that. So we have to figure out a way to fix that. Let's begin. Let's look for a pattern. We know the first thing is we start off with I. Then we know that I squared is equal to what? -1. I cubed is I squared times I, which is -1 times I, which is negative I. I cubed is I squared times I. It's -1 times I makes it negative I. I to the 4th is I cubed times I. What's I cubed? I cubed is negative I. Negative I times I is negative I squared. I squared is negative 1. So negative times negative is a positive. So I to the fourth is 1. And continue. Let's do a couple more times. I to the fifth is I to the fourth times I. All I'm doing is increasing the previous line times I. I to the fourth is 1. 1 times I is I. I to the sixth is I to the fifth times I. So I times I is I squared, which is negative 1. I to the seventh is I6 times I. I to the sixth is negative 1 times I is negative I. Last one, I promise, because I'm running out of page. I to the eighth is I7 times I. Negative I times I is negative I squared. Negative of negative 1 is positive 1. I mean, you should see the pattern of how it's working out. I to the fifth, take whatever I to the fourth is times I and work it out. I to the sixth, whatever I to the fifth is times I. I to the sixth, seventh, and eighth. But we see a pattern here. These are always repeating. It goes I1, I1. The middle two are negative. Then the next one's I1, I1. This is what you'd yell if you won a race you never thought you'd win. I won, I won. The middle two are negative. So these are the only possible outcomes of your imaginary terms. Either positive or negative, I or 1. Since they occur in groups of 4, if we take our exponent, 35, divide it by 4, whatever the remainder is will tell us what the answer is. If the remainder is 1, the answer is I. If the remainder is 2, the answer is negative 1. If the remainder is 3, it's negative I. And if there's no remainder, the answer is 1. So we can look at it this way also. 4 times what? How many times is 4 going to 35? 4 times 9 is 36. That's too big. So 4 times 8 is 32. This is your remainder. So I to the power 35 is the same thing as negative I. I to the power 97. Four goes into 9 how many times? 2 times. 4 goes into 17 how many times? 4 times 4 is 16. And there's your remainder. Our remainder that says 1, so our answer is I. That's how it works. If you have a higher exponent for I, divide it by 4, whatever your remainder is, that's your answer. That refers to what your answer is. Ta-da, we're done. Any questions? Yep. Because this sequence always repeats itself in 4. If it repeated in 5 or 6, let's say 6, we divide by 6. So we have to model it first to see if we see a pattern. Any questions? All right, we're finished 6 minutes early. Damn it. All right, everybody. Then since there aren't any questions,